What if I told you one of the most breathtaking views of a stellar nursery, a place where stars are born, is practically in our cosmic backyard? This isn't science fiction. This is Chamaeleon I, and it's helping us unlock the secrets of star birth. This incredible vista is the Chamaeleon I dark cloud, part of the closest star-forming complex to Earth, roughly 500 light-years away. It's a giant molecular cloud, packed with the raw ingredients for new stars. This particular image, looking like a cosmic masterpiece, was captured by the Dark Energy Camera, or DECam, on the Victor M. Blanco 4-meter telescope in Chile. While DECam's main job is to study dark energy, it also gives us these amazing portraits of the universe. So how do stars actually form in a place like Chamaeleon I? It starts with these vast cold clouds of molecular gas, mostly hydrogen, and dust. Within these clouds, denser pockets begin to contract and collapse under their own gravity. As they shrink, they heat up, forming what we call a protostar. If enough material gathers and the core gets hot and dense enough, nuclear fusion ignites, and a new star is born, shining its light out into the cosmos. Chamaeleon I is buzzing with this activity, primarily creating young, low-mass stars. Let's take a closer look at this stunning DECam image. Those inky black regions? That's super dense interstellar dust, so thick it completely blocks visible light from anything behind or within it. This is where future stars are still hidden, waiting to emerge. See these brilliant blue patches? These are called reflection nebulae. Here, the dust isn't hiding stars, but is actually close enough to young, hot stars to scatter their blue light towards us, like a cosmic fog illuminated by celestial headlights. The bright one near the center is Cederblad 111, and that C-shaped one above it is Cederblad 110. There's also an intriguing orange-tinted feature called the Chamaeleon Infrared Nebula. This isn't just reflected light, it's a window into the star-forming region, sculpted by powerful streams of matter flowing from a very young, low-mass star hidden within. And scattered throughout, you might spot these small, faint red patches. These are Herbig-Haro objects. They glow when jets of gas, blasted out from other newborn stars, collide with the surrounding gas and dust at incredible speeds. So what kind of stars are being churned out in Chamaeleon I? A census back in 2017 found around 226 stars, and even some brown dwarfs, which are like failed stars that didn't quite get massive enough to start fusion. The majority are low-mass red dwarfs, the most common type of star in our galaxy. Star formation in Chamaeleon I's main clusters kicked off about 3 to 6 million years ago, and while it's still happening today, the pace is gradually slowing down. There's another fascinating piece to this puzzle. The entire Chamaeleon complex, which includes Chamaeleon I, sits on the edge of a vast region called the local bubble. This is an area of sparse hot gas in interstellar space, thought to have been carved out by a series of ancient supernova explosions. It's believed that the powerful shock waves from these supernovae swept through the region, compressing the gas and dust in the Chamaeleon clouds, and actually triggering the burst of star formation we see today. This might also explain why nearby clouds, Chamaeleon II and III, show much less star-making action. Images like this one of Chamaeleon I aren't just pretty pictures, they are cosmic laboratories. By studying our closest star-forming regions, we learn about the birth of stars like our own sun, and ultimately, the formation of planets and the conditions for life. It's a reminder of the dynamic and ever-changing universe we inhabit. What do you find most fascinating about Chamaeleon I? Let me know in the comments below. If you enjoyed this journey to our stellar neighborhood, please give this video a thumbs up, subscribe to QuickByte Science for more cosmic adventures, and check out our short on this topic for a quick recap. Thanks for watching.